Have you ever wondered, does time truly flow at a constant pace? Is space really smooth and flat? And is it true that everything stays still if we don't touch it? If those things were true, then our universe would be a perfect clock. But the truth is, the universe doesn't operate the way we once believed. Everything changed in the early 20th century, when a man with wild hair named Albert Einstein stepped forward and declared, "Space and time are not fixed. They can bend." From that moment, relativity was born, overturning centuries of traditional understanding, opening the door to black holes, time travel, and a universe that behaves like a stretchable, flexible fabric. Einstein's theory actually consists of two major parts. 1.1 Special relativity, 1905, focuses on physics without gravity involved. It states that the speed of light is constant in every reference frame, and that time and space are relative to motion. This leads to surprising concepts: time dilation, length contraction, mass increasing with speed. 1.2 General relativity, 1915, expands to include gravity, and introduces a revolutionary idea. Gravity is not a pulling force, but the result of curved spacetime caused by mass. Before Einstein, people believed space was an empty stage. Time was a universal clock ticking equally everywhere. Einstein changed everything. He combined space and time into a single structure called spacetime, which can be bent, stretched, twisted, depending on the presence of mass and energy. Imagine a stretched rubber sheet. Place a heavy ball on it, right pointing arrow, the sheet sinks and curves. Small marbles rolling nearby will change their paths, not because the ball pulls them, but because the surface itself is curved. That is Einstein's gravity. Objects fall because space-time curves, not because they are pulled. In our solar system, the Sun has enormous mass, right pointing arrow, it bends space-time around it. Earth moves along the curved path, resulting in its orbit. Einstein also predicted that light would bend when passing near massive objects. This was confirmed in 1919, when starlight was seen bending during a solar eclipse. One of relativity's strangest consequences. Time does not pass at the same rate everywhere. Specifically, the closer you are to a massive object, right pointing arrow, the slower time flows. The faster you move, right pointing arrow, time slows down for you. Example: if you lived near a black hole, time for you would pass more slowly than for someone far away. In Interstellar, 1 hour near the black hole equals 7 years on Earth. This is scientifically accurate, based on general relativity. You might think relativity is far removed from daily life, but you use it every single day. Example: GPS. GPS satellites move very fast and are farther from Earth's gravity. Right pointing arrow, their clocks tick faster than clocks on the ground. Without relativity corrections, GPS positioning would be off by kilometers each day. Relativity isn't just philosophy. It's essential technology. One of relativity's most dramatic predictions is black holes, a region where space-time bends so violently that Nothing can escape. Even light is trapped. Near a black hole, time almost stops. Once you cross its event horizon, you fall toward the singularity, a place where known physics breaks down entirely. All of this came from Einstein's equations. In 2015, the physics world was shaken when LIGO detected gravitational waves. Exactly 100 years after Einstein predicted them. When two black holes collide, they create ripples in space-time, like waves on a pond. These waves prove space-time is not empty. It can vibrate, stretch, and carry motion across the universe. Classical physics treated space as a fixed stage. Einstein shattered that idea. Space responds to mass. Time responds to speed. Space-time is dynamic, a main character in the story of the cosmos. Ideas like wormholes or warp drives, common in sci-fi, suggest we might one day fold space, take shortcuts, travel vast distances instantly. Though unproven, these concepts are built directly on Einstein's framework. Relativity did not just change physics. It unlocked imagination for future space travel. Einstein's theory is more than complex equations. It's a revelation about the very nature of reality. Time does not flow uniformly. Space is not motionless. Gravity bends the universe. Moving fast can make you age slower. Black holes can erase you from existence. All these bizarre truths come from a single scientific breakthrough. The theory of relativity. A reminder that the universe is far more mysterious, unpredictable, and magnificent than we ever imagined.